Welcome back to Pentagram Prime, everybody. Today, we will be talking about energy. Energy is this thing that comes in many forms, and according to most scientists, was created about 14 billion years ago at the beginning of the universe. You know, sometime before the Terminator grew white hair. And not a single drop has been manufactured since. Recently, one of my younger viewers asked me about the difference between potential energy and kinetic energy. Specifically, I was asked, is there something that is both kinetic and potential? What energy actually is can be a bit subjective. Usually we are talking about what might be described as a closed or specifically an isolated system, nothing going in or out, including energy itself. But I will try to avoid an hour-long discussion that devolves into thermodynamics, philosophy, and a debate over subjective reality, culminating in the discussion of fringe conspiracy theories and something to do with reptile people. Instead, we will be talking about swing sets. In this discussion, you, the person doing the swinging, are the thing that has energy, be it potential or kinetic or both. And as you swing, the amount of kinetic or potential energy that you will have varies depending upon a lot of things, including how hard you're kicking, as well as the friction that makes the swing slow down when you're not kicking, or even the air around you. But mostly the amount of kinetic or potential energy that you have will depend on the position you're in relative to the center of the swing. We will, for now, ignore what happens as you are getting started on the swing because it can get a bit complicated. A person may push you, you may use your legs to get started, or a strong gust of wind could cause you to move around a little bit. There's a lot of ways it can go. But once you're going and you're stable, meaning that you're swinging back and forth and that your arc is as high as it's going to get, then you're now in a configuration where the total amount of energy that you have, including both kinetic and potential, is constant. You could almost look at it like two glasses of water. One for kinetic and one for potential. As you swing back and forth, you end up pouring some of one glass into the other glass and then back again. You will also notice that, like the water, the combined amount of kinetic and potential energy stays constant. The sum of the kinetic and potential energies in a system are commonly referred to as a Hamiltonian. So, in the middle of the arc, where you are physically as low to the ground as you're going to get, you will have essentially no potential energy. But when you're at the top of the arc, on either side, you momentarily have almost no kinetic energy because you're not moving, but a lot of potential energy because you're high off the ground. And that potential energy will soon be converted back into kinetic energy and so on as you go back and forth on the swing set. In between the top of the arc and the middle, you will have varying amounts of both potential and kinetic energy, with kinetic energy at its maximum once you are cruising close to the ground, and potential energy at its maximum when you are sitting motionless at the top of the arc on either side. For those of you unfamiliar with the concept of physical models, the swing set that I just described is exactly that. A physical model is not supposed to be perfect, and in this case, it ignores such things as the person on the swing kicking their legs, or the friction in the swing itself, as well as the air, slowing the swing down over time. By simplifying it, the model illustrates the relationship between the potential and kinetic energies in the system. And there are an infinite number of other examples of systems composed primarily of some combination of potential and kinetic energy. My personal favorite is a rocket that has zero kinetic energy on the launch pad, but has lots of potential energy at the top of its climb before converting it back into kinetic energy and making a giant fireball when it crashes into the ground. I hope you have enjoyed this discussion about the physics of playgrounds. Till next time, this is Pentagram Prime signing off.